Use the sample data and confidence level given below to complete parts A through D. A drug is used to help prevent blood clots in certain patients. In clinical trials, among 4,637 patients treated with the drug, 131 developed the adverse reaction of nausea. Construct a 90% confidence interval for the proportion of adverse reactions. So for the first part in part A, it says find the best point estimate of the population proportion P. So to find the best point estimate, we need to know two things. The sample size. In this case, we know the sample size that's given is 4,637 patients. And what is the value of X, meaning the number of successes. In this case, successes is the adverse reaction of nausea, which is 131. So recall that the point estimate is equal to the value of X over N. So let's go ahead and figure out what that value is, and then we need to round it to 3 decimal places. So we're going to take 131 and then divide that by 4,637. Okay, so let's go ahead and do that. 131 divided by 4,637, and we get 0.282, and that 2 tells us we don't need to round up. So 3 decimal places is 0.028. Let's go ahead and check if our answer is correct. 0.028, and there is our point estimate. Now we need to identify the value of the margin of error. So in order to find the margin of error, there are a few things that we need to know. So if you look in the formula, margin of error is equal to the critical z-value times the square root of the point estimate times the complement of the point estimate over the sample size of n. Well, we know that the sample size given in the problem n is 4,637. We also found that the point estimate from the beginning of part A is 0.028. Now to find its complement, we need to take 1 and then subtract 0.028. So let's go ahead and do that. So if we take 1, subtract 0.028, then we get 0.972. And now we need to find the critical value. Okay, now in order to find the critical value, first thing is we need to determine what alpha is. But we need the confidence level. So the confidence level is 90%. So that means we're going to take 1 and then subtract that 90%, which is the same thing as 1 minus 0.90, which is equal to 0.10. Then we need to take alpha and then divide that by 2. So if we take 0.10 and then divide that by 2, that's going to give us 0.05. So that means now we want to look for the area in the standard normal distribution. So remember that the standard normal distribution has the bell curve, and then that means we're looking for this z critical value that has an area to the right of 0.05. So that means we're going to use this shaded area here to the right. Okay, and so that shaded area to the right represents 0.05, and that would be 0, 0. So what we're looking for is what is this critical value, that critical value of when z is going to be greater than or equal to what critical value that's going to give us an area of 0.0500. Okay, so we're going to go ahead and open up StatCrunch to help us with this. So if we go to StatCrunch, we're going to go to Stat, Calculators, and then scroll all the way down to Normal. We know that our mean is 0, standard deviation is 1. We want to make sure that the inequality is pointing to the right because we want the area that's shaded to the right. And then here we're going to put in the area, which is 0.0500. Select compute. And now what is the critical value? Well, the critical value is 1.64. So that's what we get, 1.64 for our critical value. Okay, now we can go ahead and then plug this into our calculator. So we're going to take 1.64 and then we're going to multiply that by the point estimate of 0.028 times the complement of that, 0.972, and then we're going to divide that by the sample size of 4,637, and they want us to round that to 3 decimal places. So let's go ahead and do that. So opening up our calculator, we're first going to find out and simplify what's inside the radical. So we have 0.028 times 0.972, and then we're going to divide that by the sample size of divided by 4,637. Okay, now we need to take the square root of that number, so we're going to take second square root of that answer, and now that gives us that result, and now we need to multiply it by 1.64. So multiply that by 1.64. Now we need to round that to 3 decimal places. That 9 is going to tell us to round up, so we get 0.004. So let's go ahead and check and see if that works here. So over here we're going to put in 0.004, press enter, and there we get the margin of error. Now we need to construct the confidence interval. Okay, now before we construct the confidence interval, we need to check the requirements to construct the confidence interval used to estimate the population proportion are met. So these are the requirements that are shown below. First of all, the sample is a simple random sample. Number 2, the conditions for the binomial distribution are satisfied. And there are at least 5 successes. So there's 5 out of the 131. And there's at least 5 failures because there are more than 5 failures there. Now what we need to do is to construct the confidence interval. So we need to write down what was our point estimate that we found at the beginning of the problem. Well, we found the point estimate was 0.028. And the margin of error was 0.004. So now let's go ahead and use that to find the confidence interval. So we're going to take the point estimate of 0.028 and then subtract the margin of error of 0.004. And then on the right side, we're going to do the same thing, 0.028, but now we're going to add the margin of error. So now let's go ahead and figure that out. So 0.028 minus the margin of error 0.004, which gives us 0.024. And then 0.028 plus 0.004. That gives us an upper limit of 0.032. Let's go ahead and check our result. So here, the lower limit, 0.024. And then the upper limit is 0.032. And that checks. Now we need to write a statement that correctly interprets the confidence interval and then choose the correct answer below. So we need to know that using the confidence interval, we want to make sure that this value is going to be within this confidence interval. And we constructed a 90% confidence interval. So we would say 1 has 90% confidence that the interval from the lower bound of 0.024 to the upper bound of 0.032 actually does contain the true value of the population proportion. So we would say it would be D. And there's our result.